Okay. So till now we have seen services like AWS Glue, AWS Redshift, we have seen S3, some Lambda functions we have seen, Athena we have seen, DynamoDB we have seen. So most of these services are like, if you ignore DynamoDB, are actually processing batch data or batch records. They are processing, or you can say a batch data pipeline we are creating with the help of these services. Now, what is the difference between batch and real-time service? So, see, when I process some records, when I talk about example of our banking process, like when, or any other process, we process the records. Once those records are processed, we transfer them into our cloud sources, and then we process the data pipeline, and then we analyze that particular data in our Redshift or in our data warehousing services. Maybe we can connect that with some cloud visualization services, maybe with some machine learning services. We can go ahead and connect those things. Okay, but this process takes time. Okay, first of all, for complete day, we are actually taking the data, we are collecting it, we are pushing it into cloud services, then using data pipeline, we are processing it, and then finally we are making it presentable on our dashboards. And this batch can be of daily batch, this can be a weekly batch, or can be monthly or yearly batch. Okay. Here, the information that is getting generated is taking its own time to getting represented on the dashboards, such as the transactions that we made today or the purchases that happened on an e-commerce website are getting reflected a day after at least on batch side or on the dashboard side. But in the real-time process, as and when the data is getting generated exactly at the same moment, we try to represent that on the dashboards or on the ML services or any analytical tool we push into it. The difference between in these two services is like batch is we are first storing, then processing, and in live one we are directly processing those services. Okay. For an example, if I talk about use cases, maybe some sensors data that is getting generated from the aircraft or airplanes. Okay, if those sensors are generating data that is having health conditions of some sensors of that particular aircraft, and that we are seeing on the dashboards, and according to it, we are reacting it. If we see some issues, if we see some warning, we are reacting to it because that is live data. As and when it was generated by the sensors, it got reflected on the dashboards. But just in case if we are doing batch there also, like this morning, aircraft presented some issues with the data, and in the evening time or in the next morning, if we detect that, then it makes no sense to have that information. Okay, it was something very critical. We needed to solve that as and when it was generated. So this kind of process where we generate or process or react to data in live environment. Okay, maybe aircraft, maybe some patients data. Like nowadays, we have multiple smartwatches that is sending the records of the patients every second to the servers, and if they found any issues, that is generating some SOS message, maybe calling to ambulance or relatives. So those kind of use cases can be built around the live data processing. Okay, nowadays some luxury brands like Mercedes and other companies are actually also tracking their cars in live environment. Okay, so in live environment they track the sensors, the car sensors, and there are representatives sitting behind the scenes who are tracking that information. And if they find any issues with the engine, with some gears or anything, they quickly respond to those car owners and tell them that you need to bring your car or bring your vehicle to the for service or to the factory. Okay, So these are the use cases of the live data processing. So now I will take a pause here before starting the Kinesis data streams. If you got the idea between batch data processing and the live data processing.
This is somehow I got
Again?
yeah, somehow I got the idea. Yeah, you were saying that the data is like means we need to process it when it data is generating. That time we'll use this data stream, but the batch processing purpose like where we will store and then process, then we'll use other whatever is there.
So see, yeah, actually you're right, Pravas. But nowadays it is said data loses its value with the time. Okay.
Yeah, right.
If some data is generated today, and if I process that, if I use the data today itself, then it's going to give me more value than it's going to give me tomorrow. This means if I do some, let's say if I do some exit polls today in some state, okay, then obviously that data is going to give me more help in comparison to the data that I had 5 years back. So with every second or with every minute, you can see data loses its value from the time it is getting generated. So if the airplane responds some issues in the machines, and if you detect that after 3 days uh, there's no value for that, because it might be in these 3 days the aircraft might not, it might not finish its journey. So that's a very unfortunate thing. And those kind of accidents we can predict and prevent using the data engineering. So data engineering is not just beneficialing the our companies to enhance their capabilities, enhance their user experience. Sometimes it is actually helping saving lives. As I said in the medical emergencies, it does help. Okay, the heartbeat patterns, the blood oxygen level, these are not just jokes. I mean, if you're using a good machines, then these can actually save your life at the critical moment. So now, talking about live data engineering, we have Amazon Kinesis family in AWS environment to process and solve live data for us. Okay, the first one that we have is Kinesis data streams. Second, we have Kinesis data firehose, and third, we have Kinesis data analytics. We are going to talk about these three services one by one. So this tool, Amazon Kinesis, as its definition says, it makes it easy to collect, process, and analyze real-time streaming data to get timely insights and react quickly to new information. So the responsibilities of Amazon Kinesis is to collect the data, process the data. Our process means transferring the data from one point to another point. Okay. And we can also use Kinesis Analytics to analyze the data in real time. We can create live dashboards, we can run live queries, or we can do live data processing and data transformations. Okay. Amazon Kinesis offers us the capabilities to cost effectively process streaming data at any scale. This means we do have flexibility of compute power also. See, every resource needs some compute power. These Kinesis data streams also need some compute power or capabilities. And these capabilities, as and when the requirement goes high, we can enhance the capability, and as and when requirement comes down, we can decrease the capability. Okay, and we have the flexibility to choose the best requirement for our application. That means, as I mentioned, we have three options available from the Kinesis family. That is Kinesis data streams, Firehose, and analytics. Okay, with Kinesis, we can ingest real-time data. Maybe it could be videos, audios, application logs, clickstream data, IoT machines, machine learning data, analytical data, or it could be some sensor-based applications. Okay, so we can actually solve videos also, audios also, application logs also. So the one application of Kinesis, it could be also a house security thing. Okay, nowadays machine learnings can feel the emotions from the videos, not actually feel, but they can detect the emotions from the videos, and it is generating some videos, seeing the some videos, and as and when it sees some threat scene, some scenes, when it detects some issues or threatening, it can generate SOS messages to police and to your family members. So this is again one of the kind of use case of Kinesis family that you can use. Okay, so this is the use case of your Kinesis. Now how it works, we are going to see that in the architecture part. So again, the benefits, as I mentioned, it's real time. There's no lag. I mean, obviously there's like lags of milliseconds or seconds, but no lag such as minutes or hours. Okay, we are going to see the data in live. Maybe we could have 10 seconds, 15 seconds, or 30 seconds of delay, depending on how we have configured, how we have coded our parts. It is a fully managed. No need to do any maintenance, patching, security upgrades, OS upgrades. It is scalable as and when we see that the requirement or the load on the servers are increasing. Server can enhance their capabilities, and for that particular time, we are going to pay a higher amount of charges to the AWS. But as and when it sees the servers are feeling low pressure, they are not having the bulk of requirements for now, they can reduce down their capacity, and we are going to say pay minimum charges for that particular movement. Okay, so this is the introduction, benefits and features. Then we have architecture. Before going to architecture, if you have any questions, please let me know. See, why I'm actually stopping after every PPT here, because this Kinesis is kind of a topic that sometimes it's kind of a hard to ingest or digest, you can say, initial few days. Okay, that's why I'm actually taking my full time trying to give you more examples. And if you still have any questions, please let me know.
It's a fully managed service for the streaming as well. Means it's like ingestion and the data means transformation as well.
So it is fully managed for data collection, data processing, and data analytics. Like all these three activities, it's completely fully managed.
Okay. Then we can only do the ingestion and analytics on top of this.
See, fully managed means, okay, wait. Fully managed means we may no need to take care of the infrastructure for the OS upgrades. We no need to take care of its security, physical security. We just have to use that. Okay.
Yeah, no, I'm asking like, for example, means I need some data transformation and data validation that we cannot do. We can only ingest and do the analytics, I mean, with the help of this, right?
Yes,
Right?
data validations actually you can achieve. It's see, again, I'm saying servers and capabilities you have. So you can compare this, in this case, you can compare this with Lambda. So Lambda is again fully managed service, but we can code whatever we requirement we have, we can code that requirement.
Okay.
Okay, so something like that, you can assume it.
Okay.
Okay, and see, today we are going to talk about more about theory. Again, I'm going to repeat the theory a little bit in tomorrow's class, and I'm going to show you these things practically. Then when you see these things practically, it will make more, a whole lot of sense. It will make at that particular time. But for today, just try to capture this in your mind. Just try to understand the use cases, its features, its benefits. Okay. We are again going to repeat some things tomorrow, and we are going to do it practically. Then it will be making more sense. So in this architecture, if you see on my left hand side on our screen, if I just make it full screen. Okay, on my left hand side, we have data producers. Okay, these producers can be your EC2 instances. Just for example, I'm taking, okay, this can be your local machines or your on-premise machines. Your mobile devices, it could be some transactional server. It could be your IoT machines. So nowadays, actually, we do have a whole lot of IoT machines in our homes also. Those we call smart devices such as Amazon Alexa, the fans that get turned on and turned off with the voice commands, smart TVs we have, smart washing machines, smart ACs we have. So all those are actually generating the live data for you, and those are the IoT examples. That means Internet of Things. Okay. So all these machines that we have on our live left-hand side, these generates data. What if we configure these machines to send the data to our Kinesis streams that can collect that data and send it back to some maybe consumers or some storage layers, you can see. Okay, so it's like we have some producers. On top of those producers, we have configured some Python code, some Node.js code, or like any programming language that you choose as per your convenience. And then that particular code or that particular program is sending the results or sending some output to my Kinesis streams, and that output becomes input to my Kinesis streams. So as you can see, my data is flowing towards inside my Kinesis stream. Then it is going outside of my Kinesis streams. So this is this Kinesis streams is basically a channel here. OK, this Kinesis streams is basically a channel here that accepts the data from its producers, collects that, and transmits that to its consumers. OK, then it transmits those to its consumers. Again, on this consumer side, consumer can be residing on EC2 machines. OK, consumer can be your Lambda function. Consumer can be your S3 data. Consumer can be your Kinesis, one more Kinesis family, that means Kinesis Firos or Kinesis Analytics. We could have Redshift, DynamoDB, or AMR. Like any service that works with data can be the consumer of that. This means, if I talk about the example use case, we might be doing that we are fetching some data that is getting generated by some clickstream database. Those clickstream database we are transferring from using AWS Kinesis streams, and we are then transferring it to Kinesis Analytics on our right hand side. And that Kinesis Analytics service is actually running some queries on top of that data, and it is showing us the results on QuickSight or maybe Power BI or any visualization tool. OK. One more example, we might be having some transactional server that is having some transactions or some data it's having. It is sending records to Kinesis data streams. Kinesis data streams is taking those records and just saving it back in the CSV file format or Parquet file format on S3 buckets. Not necessarily that every time we are doing analysis also, sometimes we are just fetching the records and saving those records back to our S3 services. Or we might be transferring it to our DynamoDB services where we are using DynamoDB streams to capture the change data capture. We might be sending these records to Amazon Redshift for our batch processing or batch analytics. So use case, patterns, the tools and technologies required can change as per your requirement. OK, but the process does not change. Kinesis streams are responsible for transmitting the data from source to target. OK, and then sources can be a lot of sources and can be a different batch of sources, and target also can be different targets. So yes, again, I'm waiting here for questions if you have any.
Yeah, so this Kinesis part, it won't be having its own storage. It's just a streaming. It's taking the data and it is dumping to the destination.
You can say it does not have a storage, but yes, this Kinesis data streams stores the data, can store the data for 1 day to maximum of 7 days. So that means some record generated by my source here got put on my Kinesis data streams, but it was not consumed in a whole day by my DynamoDB table or my Lambda function or anything that is my consumer. It was not consumed by that. That means it was not picked up by that due to it could be anything that my target is down. My target is having throttling issues. Throttling means sources are transmitting more data that then target can consume. So it could be like it is generating 10 data per second, and my consumer is just fetching 1 data per second. That means 9 records per second are getting lagged behind. Then those 9 records are going to wait on Kinesis data streams for a 1 day. If the consumer picks those records within a 1 day time, they are going to get processed. Otherwise, they are going to get dropped. Time can be varied from 1 day to 7 days. By default, it's 24 hours. That is free of cost. But if you increase the time, then you have to pay for that.
Okay, and one more question, like EC2 is connecting with Kinesis as part of input, and then Kinesis is dropping, taking the stream data and loading to the destination table. So the source and destination, how it is connected with Kinesis? Is there user ID, password, or some jar or something?
Yes, kind of that only. If you are well within the limits of AWS, you can use IAM roles. Okay. If you are having third-party tools, third-party generators or consumers, you have to connect using ID passwords.
Okay, and that ID password is like cryptic ID password.
Yeah, I mean, it depends how much security you want.
Okay.
Is there any connector available? Means or it is like connecting means connect to any
Yes,
source?
actually, there are multiple connectors available. Okay, third-party connectors are also there. Some local connectors, some AWS provided connectors are also there. Okay. Any more questions? Think, take your time, think about it.
I have one question. Um, is EC2 instance is equivalent to virtual machine?
Yes, it is.
Okay, so EC2 instance only we are calling as a virtual machine, and then virtual machine can be Windows, Linux, or OS, depend upon the requirement.
Yes.
Okay.
Okay. Now, if you see, we have some terminologies uh, regarding our Kinesis data stream. So first, my piece is Kinesis data streams. That is the combination, or that is you can say is the transmitting part that is collects the data from sources and transmit it back to its consumers. Okay, that is your Kinesis data streams, and the definition that AWS says it's the logical grouping of shards is called as Kinesis data stream, or simply a data stream. Okay, then we have data record. That means exact record that I'm sending, or you can say exact row or exact record that I'm sending from my source or producers to my Kinesis data stream. That is a data record. Record can be your ID, name and password, ID, name and salary, location. Those can be your data record. It can be as good, as big as needed. Then we have capacity mode. So as the DynamoDB has the two capacity modes, provisioned and the one which is configured. Okay, we have to capacity modes here. Provision, actually, let me just go here actually. Then it will be making more sense. Which are service. Okay. So do remember that part. So if I, let's say if I want to go and click on Kinesis data streams, and before that, if you see some three families we have: Kinesis data streams, Firehouse, and analytics. Nowadays they have also introduced the Kinesis video streams. That is a kind of a thing. If you want, you can use that. But mostly these are the three ones that are actually used in real times. Okay. Let's say I want to create Kinesis data stream, then I can click on Kinesis data streams. I can provide some random name here. I'm not going to create this. Then this is a capacity. Okay, we can have on-demand capacity. We can have provision capacity. Provision means we are going to tell that how much capacity we need. This means we are having some idea that how much capacity we are going to require to process our records. Okay. And we can increase the number of shards, and minimum is 1, maximum is like 200. We can go ahead and create this. Okay. And if I say on demand, this means I have no idea that how much capacity I will be needing. And this is like as per the request, as per the time, as per the consumption basis, we are going to get charged here. So it is actually better if you can plan this capacity, and then you can maybe do auto scaling also, that as per your requirement. But it is advised that if you can plan this, because in that case we are going to save some money here. No difference is there. And if you see easy one is obviously on demand. Just select the on demand and you are good to go. No need to do any planning or analysis. Just click and use. But obviously it is slightly more expensive than the provisioned one. So this is your data stream capacity or data capacity, or what we have here term here. The term is here is capacity mode. So two capacity modes are there: on demand and provisioned. Then we have retention period. This is something we discussed with Varsha, that how much days we want to retain our data on our Kinesis data streams local storage. So if I just come here, I should be having some way to data stream settings. Right now I'm not having any option. Maybe after creation I should be having this option. But if you see, my capacity mode is provisioned. My shard is 1. I'm going to talk about what is shard. Retention period is 1 day. This is chosen by default. I can go ahead and edit this and make it to 7 days if required. And it says editable after creation. That means we will having the option of editing it once this data stream is created. Okay. Retention period, again I'm repeating, it is a time for that the record is going to stay on the Kinesis data streams. If it is not consumed well within that timeline, the record is going to get expire, and you can assume that that particular record you have lost. Okay, that you could not process and it got lost. Producer is something that generates the data for you, that sends the data towards your Kinesis data streams. Consumer is something that fetches the data from your Kinesis data stream or gets the data from your Kinesis data streams. Okay. Then comes the shard. So as you see here in this diagram also, okay, in this diagram also, we have small pipes, like we have Kinesis data stream, a big whole pipe, then we have small pipes. So this small pipes are called shard. So you can say the capacity, the capacity of the compute power that Kinesis data stream is going to have is defined by shard. So if you come here on the Amazon page, you see right now I am using provision shards. I am using 1, and this gives me maximum 1 MB of per second write or 1000 records per second of write, whichever is the greater at particular movement. Okay, this means if I open my file, let's say these are the records that I'm transmitting using Kinesis data streams. Okay, in this case, if my record, this is my record and its total size might be some KBs. Okay, let's say it's a 5 KB or 10 KB. Then this means I can send maximum of 1000 records per second to my Kinesis data streams. This is my write capacity. Okay, and this is the write capacity of Kinesis data streams. This means, okay, do not get confused here. This means, sorry, this means the Kinesis data streams can write with this speed to consumer. This is not its reading speed. Okay, this is the write speed. That means it can write 1000 records per second to consumers. Or if your record, single record is 1 MB, then it means only one record is going to get placed on your consumer at 1 second. If you have requirement where you want to send more than 1000 records per second, we need to increase the number of shards. If you see, I'm going to make it 2. And now I am saying that I am now going to get 2000 records per second. Okay, in this Kinesis data stream, that means 1000 records per second is my limit, and 2000 records I can send using the 2 shards of Kinesis data streams. So as I mentioned, Kinesis data streams is a logical grouping of shards. So these 2 shards together will be called as Kinesis data streams. Okay, and it's going to have total capacity of 2000 records per second write capacity. On the same side, read capacity is going to be 4000 records per second or 4 MB of per second, whichever is the greater at that particular moment. This means if your 500 records, okay, let's say you just have 500 records and those 500 records are having size of 1 MB, then that is it. You cannot transfer 1000 records per second. You are going to get transfer 500 records per second to your consumers. You are getting this point? It's the greater at that particular moment. Let me know if you have any questions here.
Can you explain shred again? I didn't understood.
See, Kinesis data stream is a combination of shards only. Okay, 1 shard is also Kinesis data streams and 10 shard is also Kinesis data stream. Now, 1 shard means less capacity or less compute power for your data stream. More shards means more power to your data streams. A single shard, if I just bring it down, a single shard can read 1000 records per second. Okay, it can read 1000 records per second, but also at the same time, this 1000 records cannot be of size more than 1 MB. Okay, if you have heavy record in the sense, like this is my small record. Okay, and if you see, this file is having size of 424 KB only, and it is having more than 11,000 records. This means even though my file size is 424 KB, 100 records are going to get, 1000 records are going to get transferred, and we will need 11 seconds to transfer this complete file to my target. Okay, because we have 11,000 records here, we will need 11 seconds for those. Why? Because still the file size is less than 1 MB. Like, even though my file size is less than 1 MB, you might say that it's transferring 1 MB per second. This means this whole file should have been moved to the Kinesis data streams target within 1 second. But it will need 11 seconds at least. Why? Because if you see, the records that I have in my file are actually 9,000. So it's going to take at least 9 seconds, and it is more than 9,000. So it's going to take 10 seconds at least. If I have 10 records only, and those are size of 1 MB or more than 1 MB. Again, I am going to need more than 1 second to transfer all those records. So it is more about the compute power that your stream is going to have. So you need to understand, and accordingly you need to provision your shards in your Kinesis data streams. Okay.
So shard is like it's a actual system, or it is just a virtual pipeline?
It is an actual compute resource that you're going to get.
Okay.
So basically, simply, if I say in simple terms, it means if you need more power, if you need more records per second to be transferred, you need to enhance the number of shards in your stream. But obviously, if you enhance the number of shards in your stream, you are going to get charged a bit more.
Okay, got it.
So now coming back to our point, then we have partition key. Okay. Now, every record that we send to our, if I come back to this architecture diagram, every record that we send to our shards or our Kinesis data streams, if I just get this one, every record that we send to our shards or Kinesis data streams, they are assigned a partition key, or you can say a primary key, like we had in the DynamoDB. Like we have a primary key or partition key, and then we have some other attributes. Same way, we have the same partition key available on Kinesis also, and that partition key is going to be divided into multiple, like based on the partition key, our data is going to divide based on a number of shards. So let's say in our stream, we have 10 shards at that particular moment. Okay, and then we have some partition key. Based on the number of shards, our function is like that behind the scene, this is going to happen. All those keys are going to get divided equally between these shards. So something like key distribution that we have in our Redshift, okay, based on this partition ID, based on these primary keys, we are going to get our data distributed. So again, here also we should not make the problem of hot partitions, or like I have explained, it is actually same concept. Whenever we see partition based on the keys, we should try to avoid partitions which are more heavy. That means that, let's say if I have India's data, and if I'm creating my partition based on cities, then I do not want all of my Mumbai's data to go on shard 1. Okay, and maybe some other tier 2 cities down shard to that. What's going to happen here? My shard 1 is going to get much heavier, and my shard 2 is going to get much lower traffic. And this condition or this problem is get called one hot partition. This means you have way too many records for one particular partition and way too less records for all other partitions. So we should try to choose a partition key or partition column such a way that it divides the data equally between all your shards. One partition key can only be present on one shard, but one shard can have multiple partition keys or different partition keys. So again, I'm repeating, this partition concept is again exactly same as Redshift's key distribution. Same approach, same logic, just the terms are different here. Any questions in the partition?
I have one question. Suppose with the state we have 10 different state of data, so we will be creating 10 different states. Or is there any limit on data size also?
No, data size, there's no limit. It's just the data speed is limited. Okay, and let's say we have 30 states and we divide that data on partition. If we take care of the partition carefully, okay, because see, obviously the Karnataka and Maharashtra are more populated states than your some states like maybe Manipur or some small states in northeast side. Okay, so we have to design a partition key in such a way that it divides directly onto all the shards.
Okay.
Okay, and then we have sequence numbers, basically just a sequence number that we get assigned to every record that we send into Kinesis data streams from the producer side. So every time when we send the record to our Kinesis data streams, it just gets sequence number assigned to it. So these are my terminologies, and then I have already explained to you about the data streams capacity, shard input output limits. Those you can actually read from here also. And then we have this is the example. Okay, this is the example of, so basically there are two methods that are available in the Photo3 SDK of Python, that is put record or put records. If you see, this is my put records example. So put record has it's like it sends a single record. Whenever a single record is getting generated, every record is going to get sent on my Kinesis data streams one by one. Every single record is getting sent. So that's why it has explicit hash key. It has partition key. This is the request syntax, you can say. Okay, you will get it more when I execute this put record in tomorrow's class. Okay, you will get to see these things practically, then it will be making more sense. Same way we have sequence number, stream ARN, and stream name. In the put records API, we are going to use put records API. We are going to send the records in multiple batches. We will have partition key and stream ARN name. So this difference you will see more practically, more sensefully when I run this codes. But I wanted to tell you that we have two APIs available that can send a record to your data streams. It is put record. Put record can send the records one by one, and put record send the records in batches. Put record can maintain the ordering. Because we are sending the record one by one, we can maintain the ordering. It's like first in, first out we will have in the consumer side. And with put record, there's no ordering. If you see here, we have sequence number for ordering. This column is here, but we do not have such column here. We just have data, explicit hash key and partition key. We have stream ARN and stream name, but we do not have this sequence number of ordering. So just a small difference between put record and put records. Don't worry if you don't get it. When I execute this, you will get it very easily. We have Firehose and data analytics. So your Kinesis Firehose is a service. So okay, till now we have talked about Kinesis data streams. So what streams can do, it can collect data and it can give it back to some consumer. Consumer can be anything. It does not have the capability to transform the data or analyze the data. So just in case, if you also want to transform the data within the fly, then what you have to do is you read the data using Kinesis data streams, and then you connect the same data with your Kinesis Firehose. Okay, Kinesis Firehose has the capability to transform the data using the AWS Lambda functions. So what happens here? It receives the input. Okay, it receives the input from Kinesis data streams. A Lambda function is connected on the fly. It transforms the data for you as per the logic that you write into your Lambda functions, and then it sends the data back to your output. It again, I'm repeating it. Output could be your S3, Redshift, API gateways, or it could be your Kinesis data streams. It could be more Kinesis data Firehose service. So chains of Kinesis family you can actually go ahead and create. Okay. And one more thing, it is not necessary that Kinesis Firehose only takes the input from Kinesis data streams. You might directly take the input from your log streams for your IoT devices, for your producers. Okay. So it is your choice whether you want to come through the way of Kinesis data streams or Kinesis data files you want to connect directly. Now here, as we have one lambda functions in between, okay, these creates a lag. By default, Kinesis data Firehouse can process data in 60 seconds. Okay, it will wait for 60 seconds, like that. That is like 60 seconds. It will collect the data. That collected data will be transferred to AWS Lambda function. It might take 10-15 minutes, 50 seconds more, and then it will give the data to your target output, choice of your target output. Okay, so this can include the delay of 90 seconds. So if you want to transform the data on the fly, then this is the lag you will find. So 90 seconds to 1 minute lag you might see very normally with the use cases of Kinesis Firehose. You do have option of saving the original stream to S3 also, or to send it to some other tools also. Like you can actually do, you might create two output streams from your Kinesis data Firehose. That one is a transform stream with the lambda function, and another one is a original or normal stream, and those two you can save differently to your target locations. So this is the difference between Kinesis data streams and Kinesis data Firehose. Don't worry, we are going to do a Kinesis data Firehose example also. We are going to transform some records with the help of AWS Lambda functions. So yes, if you have any questions here.
So suppose in real time, I got a requirement and where this new source is there, new API, and I had to use Kinesis and load the data to S3. Now, those settings, the thread and other things, like is there like is there any support from AWS side? We will in the real time, I'm not sure. So whether we will be getting support for doing this setup, or like how it is, we will be alone and doing that, like.
It depends how your terms are with AWS as a company, how your organization is connecting with AWS, what kind of product they have purchased from AWS. So if you remember, when we purchase when we create the free tier accounts, we do see options. It with basic support, with premium support, with or production level supports. So obviously if you have premium support or production support, those guys are going to help you. Okay, that is a plan of purchase. Then these companies have strategic partnership with each other. Mostly consulting firms are in connect with the AWS or Azure or GCPs. This means, let's say we have a consulting firm. I'm a consulting firm. I will go to AWS and I'll say, I will get you 10 clients on AWS. Okay, but help me getting those 10 clients. Help me setting up these things. Obviously, AWS will happily do that, and they have done it for us also. Okay, so not maybe they will sit with you and code it with you, but they might guide you, and they might give you some free credits to try out some things and free credits to POCs. So that is mostly a business to business talk. We developers are mostly not involved. Fortunately, I was there to with having that POCs with the Amazon guys. So I was involved. That's why I know these things. But mostly it's a business to business talk. You guys won't be involved in these things.
Okay. So
And regarding your question, setting up these things, yes, it's your responsibility.
And suppose I have set the state parameter as a 10, but in ideal scenario for the respective source, only 5 thread is enough. So there is a 5 differences there. So this kind of best practices or this kind of evolution will be happening once my development is ready, or while doing the development or having this discussion.
See, before you can do, okay, you can connect with your consumers, business, how much record, how much traffic you are expecting. Not only on Kinesis, actually on every piece of technology that we have learned so far. Initial level of discussions, initial level of analysis is always there. Then it is like once you start, once you face these things, once you see that you are wasting some resources or maybe you need some more resources, that is actually the best practice of the best thing of the cloud, that you can decrease or increase within seconds. Okay, you can take the decisions, you can monitor, analyze, and finalize. Then you can take the decision whether you want to increase or decrease, or you want to let it go and stay with whatever you have. So these decisions comes with experience, Varsha. You have to be there analyzing it and taking these decisions. You cannot just go through some documentation or some online features, or no online process can actually guide it to you. Every project has own requirements. Every project has their own choices. So you might find a project which says solve this, which might say, I don't want any delays or I don't want any unnecessary delays in my systems. Pay whatever you have to pay, but I don't want these delays. I want 100% of 100% satisfaction to my customers. On the other hand, you might have a project which focuses more on the cost saving side because their process is not so critical. They might say, okay, even though if like instead of 2 minutes, even though if it takes 5 minutes, but I prefer saving cost. So it depends on the criticality, approach, and mindset of your clients.
Okay.
And obviously the budget also. If they don't have money, then obviously they can't pay you.
Okay.
Okay, and then the final one that we have is Kinesis Data Analytics. This Kinesis Data Analytics actually can take input from Kinesis Data Firehose, Kinesis Data Streams, as okay, and it can also output the records on these technologies only: Kinesis Data Streams, Kinesis Data Firehose, and S3, and MSK also they have introduced recently. Okay. These Kinesis Data Analytics actually can run Flink code for you in real time. 1 year back, it was simple SQL queries. Okay, it was simple SQL queries that we were able to run in the real time. Okay, but nowadays this has been replaced by Apache Flink. Now Kinesis Data Analytics works or prefers using Apache Flink. You do have, I'm not sure about now, but a month or 2 months back, we did have the SQL option also available in the legacy pages. But when it goes in legacy, that means maybe in few more months, then that particular piece will be gone. Okay, so you should be using latest things, and also in our demos also we are going to be using Apache Flink only for our live data analytics. So if the use case of Kinesis Data Analytics is that you can connect it with your Kinesis data streams, that is fetching live data for you, and then run some queries or run some code to analyze the data in real time, maybe create some dashboards, maybe create some tables, maybe generate some reports. Again, I'm repeating, if you don't get it, don't worry. When we do these things practically, we are going to get a more idea or more knowledge about these services. Today, I just wanted to give you information slowly, and that's why I'm not doing any practicals also. I don't want you to get confused here. If you don't get it, no worries. Okay, I'm again repeating, if you don't get it completely, even after the demos, no worries. If you can crack Glue, PySpark syntaxes, Python, SQL, Redshift, and Lambda, you can land any data engineering job that you want. Any company will hire you. Okay. Yes, somebody was going to ask a question.
Yeah, the Apache is Flink.
Yes.
Is it only for analytics purpose or data processing also, like streaming?
It actually is data processing only.
Okay. Okay. Not like Athena.
No, not like Athena.
Okay, got it.
Apache Flink is actually separate service. If you want, you can learn it from Google or something. But again, see, no need to go on that path. We have thousands of services. What all you will learn? Just focus on the main tools and technologies. Get a job, get your salary increased, then it's your choices if you want to improve your skills more and more. And I will say, do it. I mean, once this course is completed, please go ahead, please do practice, make yourself skilled in these technologies first, then don't stop. Maybe try and learn Azure, maybe try and learn GCP, maybe try and learn some other technologies.
Okay.
Maybe not from paid courses, Udemy courses will be sufficient. See, once you get a platform, okay, once you get a platform where you can feel a bit confident about yourself and about your skills and about your concepts, then you can learn any technologies by yourself also.
Okay. Are we covering a Flink also as a demo?
Yeah, as a demo, yes,
Okay.
we are, but as a technology, we are not.
Okay.
Okay, so this is all from mine for today. And we are going to start some demos from tomorrow. Okay.
Thank you.
Okay then, guys. Thank you.
Thank you.